Okay, so that was ionic bonds, covalent bonds. Here the electrons are sharing. When we have two nonmetals together, they're both trying to get electrons. Neither of them is willing to give up electrons. We can't form any ions. So what's going to happen is they're going to share. So we represent covalent bonding by neighboring atoms sharing some of their valence electrons, and they're going to do that in a way that gives them an octet. So let's look at hydrogen and oxygen. So what's the Lewis structure for hydrogen? How many electrons? 1. Hydrogen has 1 valence electron. We've looked at oxygen before. It has 6 valence electrons. So hydrogen and oxygen trying to work out a deal so that they can have an octet for oxygen, a duet for hydrogen. Oxygen saying, just give me that electron, and the hydrogen says, no. Well, what do? Well, let's share, okay? So if hydrogen and oxygen share, I'll share one of my electrons with you, you share one of your electrons with me. Now, hydrogen looks at his situation. These shared electrons belong to both of them because they're shared. So hydrogen looks at this bond, this chemical bond, and says, I've got 2 electrons. That's my duet rule. I'm good. Awesome. I'm happy. The oxygen now has 2, 4, 6, 7 electrons. The oxygen is closer, but still not quite there. Well, where there's 1 hydrogen atom, there's going to be at least 1 more. So here's another hydrogen atom. So the oxygen is going to share an electron with this other hydrogen atom also. That makes this hydrogen atom happy with 2 electrons, and now the oxygen feels like it has 8 electrons. These shared electrons count for both atoms. It's a little bit like children. Okay, so if you ask me how many children I have, I'll tell you I have 6. And if you ask my husband how many he has, he'll say 6. And so between us we have 6 children, not 12. Thank goodness. There would not be room. Anyway, there's 6 of them. Well, they move around real fast, though. It looks like 7 or 8. There's 6. They're mine and they're his. They're shared. They belong to both of us. So these electrons that are shared belong to both atoms that are sharing them. Does that make sense? And that's the chemical bond.
They share 2, they share 8.
This hydrogen and this oxygen are sharing 2. Okay? And the oxygen is sharing these. So 1 from the hydrogen, 1 from the oxygen, 2 over here. So if we were going to look at who's counting what, the oxygen is counting all of these, and each of the hydrogens is just counting what is being shared with it from, yeah, that didn't go very well. So it looks like some sort of weird Venn diagram. It isn't, it's just circles. Any questions? So what we call a bonding pair, that's a pair of electrons that are shared between 2 atoms. That forms the bond. So that you could say that, the children are a bond between me and my husband. We also have lone pairs or non-bonding electrons. Those are electrons that are only on 1 atom. So let me redraw water here. So there's our Lewis structure for water. This is a bonding pair. We'll call him BP. And this is a bonding pair. These are lone pairs. They're not shared between 2 atoms. They are only sitting on 1 atom. Okay, so there's lone pairs and bonding pairs, and it's important to be able to distinguish those. Well, drawing the dots and connecting them with a line is really helpful when we're first learning, but it gets a little tedious. And so oftentimes we'll just represent that bonding pair as a line and show the lone pairs as dots. So when we see this line, that is a bond, a covalent bond. That's 2 electrons. And so if you find that confusing, you can take those and just add the electrons at each end if that helps you see it better. But we often just draw them as lines. A shared pair of electrons. So Lewis' theory explains why those 7 diatomic elements, horses need oats for clear brown eyes, or Brinkelhoff, why they are diatomic. Because by sharing electrons with each other, they can get an octet, and that makes them more stable. So let's look at bromine. Bromine is one of the diatomic elements. So if we draw a Lewis structure for bromine, Br2, each of these has 7 valence electrons by itself. If 2 of those bromine atoms get together and each share 1 electron with the other atom, now they each have an octet. So they're more stable than if they were individual hydrogen atoms running around by themselves. Any questions? Hydrogen is also a diatomic element, isn't it? Each hydrogen atom has 1 valence electron. 2 hydrogen atoms get together. Hey, I'll share my electron with you if you share your electron with me. Now they count the shared electrons for each of them. They each have 2 electrons, the duet rule for hydrogen. Any questions? We can have atoms sharing more than 1 pair of electrons. So let's look at oxygen, another of those diatomic elements. So here's oxygen. Oxygen has 6 valence electrons. I draw the dots so that they're convenient for what I'm going to do with them. So neither oxygen atom is happy, right? They don't have 8 valence electrons. So they say, well, hey, let's share an electron. I'll share one with you, you share one with me. Are they happy now? They're closer, but now they each have 7. They count the shared as belonging to each of them. So 2, 4, 6, 7 for this oxygen, 2, 4, 6, 7 for that oxygen. What could they do? Share another one. Well, let's share these as well. So now this oxygen counts 2, 4, the lone pairs, 6, 8, the bonding pairs. It has 8 valence electrons. And the other oxygen does as well. That's kind of an awkward drawing. So how we usually represent it is like this. 2 lines, each line representing a shared pair of electrons, and then the lone pairs. And again, you can put them on the different places if you want. So that's a Lewis structure for oxygen. Sharing 2 pairs of electrons is called a double bond. A single bond is 1 pair, a double bond is 2 pairs. Guess what a triple bond is? 3 pairs. So the double bond, 2 electron pairs being shared. When you have 2 pairs of electrons, those bonds pull the atoms together. A double bond pulls them closer together than a single bond. And so the double bond is shorter and stronger than a single bond. I'm not going to quiz you on this or anything, but in an oxygen-oxygen double bond, the distance between the nuclei is 121 picometers. In a single bond, it's 148 picometers. So when you increase the number of electrons that are shared, the atoms get pulled closer and closer together. Let's look at nitrogen, another diatomic element. How many valence electrons does nitrogen have? What group is it in? Group 5A or group 15. So it has 5 valence electrons. 1, 2, 3, 4, 5. And here's the other one with 5. 1, 2, 3, 4, 5. So you can see where this is going, right? They can share that pair, and they could share this pair, and they could share that pair. By sharing 3 pairs of electrons, they can each have an octet. So we would usually draw this with a triple line, 3 lines, each representing a bonding pair, and then the lone pair out there. So we got Mrs. K, and we got Dr. K, and we got this triple bond. And our electrons have names: James, Zach, Tommy, Michael, Emily, and Andrew. Got a triple bond. Questions? So the triple bond, 3 pairs of electrons, that's shorter and stronger than a double bond. You can compare, oh, that's all messed up. I had to convert these from the regular format to the widescreen format, and I missed a few things. A triple bond has a length of 110 picometers. For nitrogen, a double bond is 124. So the more electrons that get shared, the closer those atoms are together, and they are more tightly bonded together. So that triple bond between the 2 nitrogen atoms makes nitrogen a very stable molecule. Nitrogen is more stable than hydrogen because it's got that triple bond holding it to another nitrogen atom.